Greetings. For today's show and tell, I thought I'd show you these desk mounted power strips and tell you why I think they're a crock of So, desk mount power strips, or stupid Toblerone things as I prefer to call them. And the main thing that bugs me with these is the fact the sockets are all individually fused. I can't see any reason for this. The cable itself is protected by the 13 amp fuse in the plug at the other end, so there's no way to overload the strip or its cable. Anything plugged in is going to have a fuse in the plug. And a fuse on the device itself, quite often. So these fuses do absolutely nothing to protect those, or to protect the cable. They only seem to serve one purpose from what I've seen, especially on the 6-way ones where the fuses are only rated at 3.15 amps instead of 5. And that's to blow if you plug anything remotely high powered into the thing. I've seen these with blown fuses in meeting rooms where the biggest thing somebody may have plugged in would be a projector. Of course, people just leave these dead sockets for the caretaker or the pack guys to find, or there's a pretty good chance the person testing it will just fail the thing instead of actually replacing the fuse. That's when they're not leaving things like this lying around, which I found the other day in an office, and yes, there is a fuse still in that. Why on earth didn't they remove the fuse? That's not the reason I'm looking at these today though, nor is it these daft data jacks which use keystones that on some models have a tendency to push through and get stuck inside the unit. This one has been pulled out of service because the rocker switch has fallen apart. Yes, those are live contacts in there. One side of the switch cracked off, allowing the entire switch mechanism itself to just pop out. This one though, this one's a cracker, literally. Following the lockdown last year, some staff came into the office to collect their computers and other equipment to work from home. When the members of staff unplugged from this one, the faceplate pulled clean out of the socket. Twice. And one of my colleagues has seen these as well. So this isn't the only one we've got in service. He's seen others fail in the same way. And those are bare contacts in there. On a conventional power strip, that couldn't happen. What if this wasn't in an office? What if this was in a primary school? Anyway, enough about the dangerous ways these can fail. Let's take a look inside and see what sort of quality you get for 5 times the price of a 4-way extension lead. Right, start at the end. There's a little spacer. And one of those with a keystone, which is surprisingly holding in on this one. Like I said, we've seen them where they tend to just, you put a lead in and the keystone just pushes through. What these are, by the way, in case you've not seen these, they'll take a network cable in the back, so you can connect it to, you patch it through to structured wiring and have a data socket on your desk. So it's literally just one of those snapped into that. There's another one. Then we have a separator and a spacer, and then we have the first of the broken sockets. Let's get the front off and see what else we've got here. Oh, crikey. Soldered in connections. No idea what they're rated at. Let's clip that out. It's marked with the terminals, and these are crimped and then soldered, so that's how they're fitted. There's no manufacturer mark on that, and that's just designed to sit into this in presumably one of a number of locations, so you can mount them that way or that way or that way, and then tighten up the screws to sandwich them in place. So as I said, no branding, no rating on it. And that'll connect through then to the next bit, which is the 5 amp in this case fuse holder. Let's sort it out. There's 2 more connections on that. So these are standard off-the-shelf fuse holders for 20mm, I believe, fuses on this. Let's pop this separator out, and we've got, oh, this one has, are they designed to split in half? No, but this one has split in half. So the socket wouldn't have been able to fall out of that, but it's not absolutely good. Let's cut the cables. Get it out. So it's just daisy chained along. The wire's bared, and well, the neutral and the earth, the wire is bared a section, crimped and soldered quite roughly. And we repeat again, this time with another broken socket. And fuse holder. Right, I didn't break that off. That's how well that was held in place. So I'm not on about this nut here. I don't care about the nut. The fact that that was very loosely, that was barely making contact there, and I can't see how it is. That is terrible. Is that going to focus? There we go. You can see that was barely held in, and just removing it from there was enough to break the contact between the two, and that would mean the broken socket in this case was it wouldn't have taken much to overheat that connection. Then we have, let's cut the incoming cable. There's some melt marks there from the soldering process, I assume. Someone's caught it with the iron. And you've got a switch which is rated at 16 amps. So at least the switch is rated highly enough. So that's the 4-way of whatever brand this is. There's no actual branding on the back, it's just a generic desktop power pack unit. Let's take a look at the 6-way, see if that's any better. It's lucky in fact that this case is plastic, because when those sockets pushed through, those contacts would have been pushed straight into the metal backing of the unit. So that wouldn't have ended well. Just cut the cable out, so it's going to push the whole thing out. There we go, in one piece. And let's look again at the quality of the soldering. Now that's okay, so that is actually held this time. doesn't go through the terminal, but it's actually held fairly solidly there. But it's quite it's the most professional of jobs, I'd say, in terms of joining these together. Maybe that's just my opinion, or maybe everyone else thinks it's shit as well. So that's those plastic ones. Let's take a look at the metal clad ones. And these seem to be taking the mickey because they've got tri-wing screws on the one side and security flat blade screws, these 2-pin ones, on the other. So let me grab my tri-wing screwdriver because that's not too far away. I'll get that open. Right, you can see these are missing their keystones already. They've already broken loose and been just taken out. So we've got those. Then we have, again, there's a spacer. That's good, between the mains voltage and the low voltage side. I'm going to cut the cables here just so we can slide it out in one. Interesting choice of colours. So we've got a combination of new and old wiring colours here, although I suppose being inside a machine unit, it doesn't really matter. We've got double pole switch this time, or at least it was, and what is actually solid core equipment wire linking them together, whereas the other one was flex. This has got equipment wire actually going through the terminal, so it's still soldered again, but it's been threaded into the gap and then filled with solder, so it's a lot more secure, hopefully. And those seem to hold okay onto the, oh dear, spoke too soon. Earth wire just broken off there. Looks like, you know, it could be a dry joint, or it's probably just that awful lead-free solder stuff. The rest are holding in. So these sockets are different type. These are MS589. There's no current rating on them unless you read on the front where it's actually stamped on. And they've got these standard push fit fuse holder modules snapped into the hole. It's an interesting little module. It's a complete recessed socket designed to go behind a plate like that. Would that fit with one of those other plates? No, it's not designed for those. But interesting little module, and it's actually clicked together in a few places. So might as well pop it open because this is not going back into service. There we go. Not a lot to it really. So that's what's in those ones. So if you put off using one of these damn things, what are you going to use instead? How about a power strip that would normally be used in a networking or computer equipment rack? Maybe not one quite as big as that, but it does the job. These 15 sockets are each rated at 13 amps, and I've yet to see one of these fail. These ones with the screws at the top or bottom. Nor have I seen the ones with the screws on either side. These are Wandsworth ones. I've never seen these fall apart either. The problem you can get with these strips is when they've been running for a long time, and I think this strip was running for about 20 years straight, what can happen is the switch contacts will stiffen up and it becomes gummed up, or you can't switch it on or off. What I've done with this one is I've replaced it, I've bypassed the switch completely and put this push button in just to fill the hole. I could have fitted a neon indicator instead, but I've run out of those as well. With that switch in place, that should see another 20 years at least. So how about this 6-way one? Well, maybe. I've seen old ones lose their faceplates the way this did, but I've not seen that happen in about 20 years, so hopefully they're improved somewhat. This one's got a different issue though, which is why it's not in a network cab anymore. This end socket won't properly accept a plug anymore. Let's pop it open and see what's wrong with it. It's got a paper sleeve in the back to protect against any terminals coming into contact with the rear. Well, that was interesting. Of course, with that other one, those were also soldered terminals, but fortunately it wasn't designed. It'd be quite difficult for that to break off and push into the unit. Not impossible though, but I digress. Let's take a look at this. That's more like it. We've got a bus bar, and a cracked socket, so that's why that's gone. See, in fact, sorry, we have, that's interesting, we have one socket which has fallen to bits, which is that one, which looks like, would that take, I'm not sure if that's a standard fitting. No, it's not. It's different pin spacing to those. So that one fell to bits. This one's cracked. This one's cracked. These ones are... This one's cracked. So there's a crack in this one at the end. You can see that opening up there. That one's okay. That one's okay. That one you can see is breaking open as well. And that one, well, there's not much left of it. But this has a bus bar designed through the unit rather than individual sockets. Incidentally, that 15-way one has 2.5 square mil cable, flexible wires running as a daisy chain right the way through. That's how that's connected internally, and all the sockets in that are rated at 13 amps. Nice chunky switch with the connections soldered on. And while we're in here, let's take a look at this surge protector. What I should say about this unit is it hasn't seen a lot of service in terms of cables being plugged in and unplugged. It'll have had probably 3 or 4 plugs in each of those sockets in its lifetime. So that is not a good service for that's not a good sign of quality in terms of that unit. And it wouldn't have been drawing heavy current. You're talking about 30-40 watts tops in each of those sockets, so not a lot. And inside, here's the surge protector, and here's the schematic. So I guess that leaves us with the ordinary power strip. Again, neon illuminated switches can be a problem as the neon slowly cooks the plastic, which is why this one, which I normally use on my workshop, on my workbench out in the garage, has a different switch fitted. And I've also had to take one of these out of service the other week for the same problem. The switch was barely holding in place. My recommendation would be a simple 4 or 6-way power strip with its own fuse if you want to keep Keith Lard happy, even though there's an identical one in the plug at the other end, and a non-illuminated switch so you can turn the lot off when you're not using them. And use a reputable brand and not some £3 job from Amazon. Hope someone finds this useful. Thanks for watching. I'll see you soon.